we are going to discuss whole engineering mathematics. Initially I get that okay, in square brackets I have to write down 5 rows, 5 columns, and there will be 25 entries, right? So a basic structure we are able to ready for that. If I'll talk about any topic, first you would understand the basics and like what is a higher knowledge you require to get the question. So we are going to cover all the concepts. What would be the correct approach to solve this kind of a problem? Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE Computer Science and Data Science. So we are going to start a series on YouTube in which we are going to discuss whole engineering mathematics, and we are going to discuss all the concepts with questions so that you would understand the basics of the concept. That like if I'll talk about any topic, first you would understand the basics and like what is a higher knowledge you require to get the question. So we are going to cover all the concepts and then we are going to solve good level questions, or I can say that gate level questions, so that you would know what would be the correct approach to solve this kind of a problem. Because sometimes you get a solution but you face a problem in getting the right approach, which would take least time, and there are less chances of having errors. So we are going to discuss that as well. So this series would be helpful who are preparing for the GATE 2026 or further years 2027. So stay tuned. Stay with us for all the videos which would help you in your GATE preparation. So if I'll talk about engineering mathematics, it comprises of 3 subjects. Engineering mathematics. So first, engineering mathematics. So first we are going to cover linear algebra. Then after completing that we'll move to calculus, and then we are going to cover probability and stats as well, right? So we are trying to provide best content here, right? So make sure that you would be able to cover all the concepts, and if you feel like you have any doubt or any question, just let us know in the comment section. We'll reach to you, or just let us know whatever you are facing so that we can help you out. And also you would get the notes and all other things. You can find out the details of that in description as well. Okay, so in linear algebra we have topics that is matrices and rank. First we'll start with matrices, then we'll discuss types of matrices, then we'll move to rank. Before that we have to understand row reduced echelon form, then system of linear equation, and then LU decomposition. So we are going to cover topics one by one. So let's start today with the topic matrices. So the first question arises when we discuss matrices, that what is a matrix? What is a matrix? So we all know that if I'll take square brackets and arrange numbers in rows and columns, then I'll get a matrix. So if I'll write down here 1, 2, 3, 4, 5, 6, 7, 8, 9, this is my matrices. If I'll count how many rows I have 3 rows and I have 3 columns here. 3 rows and 3 columns. So matrix, I'll arrange numbers in rows and columns, I'll get a matrix. And if I'll talk about let's say this matrix 1, 2, 3, 4, 5, 6, it is matrices in which we have 2 rows and 3 columns. 2 rows and 3 columns. The question arises that how we are going to represent a matrix. So any matrix I'll represent using a capital letter. Let's say this is A matrix and this is my B matrix. This is A matrix, this is B matrix. Now I know one thing, that this is first column, second column, third column. First row, second row, third row. Now I want to represent the elements of a matrix, this one. So how do I represent that? I'll represent it with a small letter A, and because it is coming in first row and first column, I'll give it a special value A11. So A11 is 1. Similarly, this value is first row, second column, A12. This is second row, third column, first row, third column, A13. Similarly, this one is A21. This one is A22, and this one is A23, right? This one is A31, This one is A32 and this one is A33. Similarly, you can represent the this B matrix as this entry is B11. This, let's say, I'll ask you what is this entry. It is in second row and third column, B23. Right? So we are starting from very basic so that you would understand all the concepts if anyone does not know. So if you are if you do not know anything about mathematics, engineering mathematics, you can follow this series. Right? So this is my matrices. Now next come is order of a matrices. What is order of a matrix? Order of matrix is nothing but number of rows into number of columns. And this is not a multiplication sign. It is just a cross sign, right? Number of rows cross number of columns. So that is our representation, this cross sign. So what is the order of this matrix A? The order of this matrix A is 3 cross 3, right? 3 rows, 3 columns. Similarly, order of this matrix is, order here is, because we have 2 rows, 3 columns, so order is 2 cross 3. Order here is 3 cross 3, order here is 2 cross 3. Right? That is order of a matrix. And order of matrix would be helpful to define the structure of a matrix. Once I know, let's suppose somebody says that, what is the order of a 5 cross 5 matrix? Let's write down a 5 cross 5 matrix. So that means initially I get that, okay, in square brackets, I have to write down 5 rows, 5 columns, and there will be 25 entries. Right? So a basic structure, we are able to ready for that. Next question arises, that is matrix operations. Right? What are matrix operation? So we have seen that the matrix operation, that first one is add. I can add any 2 matrices, A plus B. I can do that. The only condition required is that A and B have same order. I can find out A plus B if A and B have same order. Addition and subtraction. You can discuss both. These two would be possible. Addition of 2 matrices or subtraction of 2 matrices would be possible if A and B have same order. Otherwise, you would not be able to find out addition of 2 matrices. So you would be able to, if they have same order, then you would be able to find out A plus B and A minus B. And how would you find out A plus B and A minus B? Let's suppose we have this matrix 1, 2, 3, 4. And another matrix we have is 3, 4, 5, 6. What you would do? These are 2 matrices. This is A, this is B. You are going to find out the sum of 2 matrices. So what is A plus B? You would add individual entries. 1 plus 3, 4. 2 plus 4, 6. 3 plus 5, 8. 4 plus 6, 10. So this is your sum of 2 matrices. Similarly, you can find out the subtraction. You have to subtract individual entries. Next comes here multiplication. And one thing you can notice here is that either you would write down A plus B, it would be same as B plus A. A minus B would not be equals to B minus A, right? That we all know. So A plus B is equals to B plus A. We have this rule here. Next we have is product of 2 matrices. Product of 2 matrices. Product of 2 matrices. Now, for A matrix of order M cross N and B matrix of order P cross Q, the product AB exists. Product AB exists only if and only if भी लिख सकते हैं. If and only if number of columns in A equals to number of rows in B. That means N is equals to P. Then I'll be able to find out product of 2 matrices. Otherwise, I'll not be able to find out product of 2 matrices. And let's say we have this matrix 1, 2, 3, 4, 1, 0. And let's say I have one matrix 3, 1, 4, 5. This is my matrix. So this is matrix. Let's say this is my A matrix. This is my B, or let's say 7, 1. इसको ऐसे लिख लेते हैं 2, 1, 1, 0, 1, 5, 1, 2, 1. This is my B matrix. A matrix of order, A is of matrix of order 2 cross 3, B is of order 3 cross 3, right? You can write down order of a matrix at the end of this square brackets, right? A small 2 cross 3, and it is of order 3 cross 3. Now you would be able to find out product of these two matrices only if number of columns in A is equals to number of rows in B. So here number of columns in A is equals to number of rows in B. So you would be able to find out the product. And how you are going to find out the product? You would take the first row and multiply it with first column. Just take this first row and multiply it with first column. How you are going to multiply row and column? So you would see that AB would be this matrix AB. How would you get? So you would 1 into 2 plus 2 into 0 plus 3 into 1. That means what happened here? 1 gets multiplied with 2, 2 gets multiplied with 0, 3 gets multiplied with 1. Similarly, 1, 2, 3 gets multiplied with 1, 1, 2. So 1 into 1, I am writing it directly. 1 into 1, 1, 2 into 1, 2, and 3 into 2, 6. 1 into 1, 1, and 2 into 5, that is 10, and 3 into 1, that is 3. That is 3. And 4, 1, 0 gets multiplied with this. 4 into 2, 8. 1 into 0 would be 0, and this would be 0. Similarly, 4 into 1, for we'll take second row and the columns, each of the columns of B. 4 into 1, 4, and 1 into 1, 1, and then 0 into 2, 0. Then 4, 1, 0 would get multiplied with this entry, right? So you can see that second row multiplied with third column. So you would get 8, 2, 3 entry. Second row, third column entry. So 4 into 1 plus 1 into 5, and then 0, 0 into 1. So the product of two matrices here, what would be AB here? AB here would be 2 plus 3, that is 5. 6 plus 2, 9. 10, 14, it would be 8, it would be 5, it would be 9. So this is product of a matrix, and you can see that the product order of AB, the product you get has order 2 cross 3. और वो 2 cross 3 order कौन सा होता है? ये वाला. Number of rows in A and number of columns in B. So order of AB, if A is M cross N, B is P cross Q, product exists if N is equals to P, and order of AB is MQ, M cross Q. Guys, if somebody knows all these things, like, because this is matrix operation only, we are going to dig deeper into matrices as well. We are going to discuss questions as well. So this is start. So we are also covering all the basics so that further you would not have any confusion, right? So order of AB is M cross Q. Now, next is transpose of a matrix. So the question arises, what is transpose of a matrix? So what would you do? Let's suppose you have a matrix A, 1, 2, 3, 4, 5, 6. This is my matrix. And transpose of a matrix I denote using A transpose. What we do in A transpose? We'll convert rows into columns, right? So that means, or interchange rows with columns. So first row we have is 1, 2, 3. So it would become first column. 1, 2, 3. Second row is 4, 5, 6. So it would become second column, 4, 5, 6. So you can see that transposes interchanging rows with columns, you would get your transpose, right? And you can see one thing, that order of a matrix is 2 cross 3. So transpose would be 3 cross 2. Order would also get reversed because we have interchanged rows with columns. So yeah, let's discuss some of the properties of transpose. So what are those properties? It says that transpose of transpose is A. That is also correct, because if you would take transpose here, like if you would take again transpose, A transpose, transpose, just take a transpose here, you would get 1, 2, 3, 4, 5, 6, right? So you would get the matrix itself A. You would get the matrix A here. Now, another one is that A plus B transpose, A plus B transpose is equals to A transpose plus B transpose. You can do that, A transpose plus B transpose. One more thing, we have left in product of two matrices. One more thing you have to remember here is that one of the thing is that product of matrices is not commutative. AB may or may not be equals to BA. This is one of the property. Second one is, but this product is not commutative, but it is associative. What does I mean by associative? First I'll do BC or I'll do AB first. I'll get the same result. So matrix multiplication is not commutative, but it is associative. So just remember that. Now, let's get back to this A plus B transpose. So you can take transpose of A individually and transpose of B individually, and then you can add, you would get the same result. Another thing is R into A transpose. So if you would take R outside, if you have a scalar multiple in a matrix, so how do you multiply a scalar with a matrix? Let's suppose you have this. So you can write down 1R, 2R, 3R, 4R. That means you have to multiply that R in the whole matrix, right? So R into A transpose would be RA transpose. So it does not impact, this transpose thing does not impact on any scalar. Next thing is AB transpose is equals to B transpose A transpose. This is an interesting property. Like you cannot say that AB transpose is equals to A transpose B transpose because it is not commutative. If it is commutative, then it would like work, but it is not commutative, so it would open as B transpose A transpose. Similarly, if you have k number of matrix, A1, A2, AK, any number of matrix, if you would take a transpose, they would open it in a reverse manner. AK transpose, AK minus 1 transpose, and it move up to A1 transpose, right? And inverse we'll discuss later, but right now just remember the property. Either you would take a inverse of a transpose or transpose inverse, that would be same. Now next thing we have is types of matrices. That is important thing because there are so many questions comes on types of matrices, or not exactly on types of matrices, but let's suppose you have given that this is a symmetric matrix or this is a square matrix. So you should know what is symmetric matrix, and then you have to solve it further whatever they have given in the question, right? So we'll start the matrix with one by one. What is a row matrix? So row matrix is a matrix in which we have only one row. So row matrix is a row matrix is a matrix in which we have only one row. Only one row. Column matrix would be only one column. Only one column. Right? Null or zero matrix, all the entries. So I can say here null or zero matrix is all the entries are 0, then it is said that this is null or zero matrix. So let's say any matrix you would say of any order, it does not matter, it would always be null or zero matrix. So in row matrix, order would be always m cross 1. Column matrix, we'll always have one column. So we have this kind of matrix. So sorry, it would, for row matrix order would be 1 cross m, and for column matrix it would always be n cross 1. Because we'll always have one column. But for null matrix, it can have any order m cross n. We can have any order, it does not matter. Right? Now, next thing we have is square matrix. A matrix in which number of rows equals to number of columns, that is why square matrix. Matrix in which number of rows equals to number of columns, then I have a square matrix. So if order is of this type n cross n, then it is a square matrix. It is a square matrix if order is n cross n. Now next thing we have here is diagonal matrix, right? So what is a diagonal matrix? A square matrix in which all non-diagonal entries are 0. Non-diagonal entries are 0. what is a diagonal of a matrix? So if I'll take, this is a matrix. First of all, it should be a square matrix. Let's suppose this is a matrix 1, 2, 3, 0, 0, 0, 0, 0. So the middle entries in each row, the middle line on which all the values lies should be non-zero. That is my diagonal, and other than that all the entries are 0, right? So that is my diagonal matrix, and it can be of any order, 2 cross 2, 3 cross 3, 4 cross 4, because it is a square matrix, so order would be always n cross n. Now what is a scalar matrix? Scalar matrix in which, so I can write down a square matrix in which all diagonal entries are 0 and all non-diagonal entries are 0 and diagonal entries are equal. That means I cannot write down 1, 2, 3. There should be only one scalar, right? Single scale. So if I'll write down 1, let's say 2, 2, 2, or I can place instead of 2, 3, 4, 5, any number, but it should be on all 3 values, right? So that would be my scalar matrix. Now next thing comes is identity matrix. So what is an identity matrix? In which a square matrix in which all non-diagonal entries are 0 and diagonal entries are 1. So that means identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Of order 2 cross 2, it would be 0, 1, 1, 0. The property identity matrix has is that if you would multiply with any matrix, let's suppose this A is any matrix and I'll represent identity matrix with I, right? If you would multiply it with I, it would not make any impact on A, it would remain A, right? If you would multiply A with identity with any matrix from left hand side or right hand side, you would get the same result. You would get the matrix itself. So that's why we call this as an identity, because it does not make any changes in my matrix. Right, now let's see further. Next thing we have is trace of a matrix. So what is a trace of a matrix? So now we know what are the diagonal entries. If I'll take sum of all the diagonal entries in a square matrix, obviously na diagonal की बात हो रही है, तो it would be a square matrix. Sum of all the diagonal entries in a square matrix. So in a square matrix, I'll take sum of diagonal entries, so then I'll get my trace. So let's take one example. We'll have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So here what would be, let's suppose this is my matrix A. If I need to find out trace of A here, what it would be? It would be 1 plus 5 plus 9. That means 15. Trace of A is 15. Right, trace of A here is 15. Now next we have is property of trace of matrix. So we have some properties. So if I'll multiply a scalar with a matrix lambda, or either it can be R or either it can be C, any scalar, you can either find out trace of A first, then multiply C, or you would multiply C with the matrix first and then find out trace. You would get the same result. Then trace of A minus B is equals to trace of A minus trace of B. Similarly, trace of A plus B would also be, ये plus minus कर लो इसको, right? It would be plus and minus. So if it is plus, let's do it plus minus. So if it is plus, then you have a plus. If you have minus, so they are minus respectively. Trace of AB is equals to trace of BA. We know one thing, that AB is not equals to BA, but trace of AB is equals to trace of BA. Next thing is trace of A is equals to trace of A transpose. Right, this is what transpose. So trace of, either you would find out trace of A or either you would find out trace of A transpose, you would get the same result. And why is that? Because A and A transpose both have same diagonal entries. right? They do not have different diagonal entries, they have same diagonal entries. We can check that as well, because in in transpose diagonal entries does not get changed. You can see 2 cross 2 hai. So if I have any square matrix, right, because trace can only be found out for a square matrix. Now trace of identity matrix is n, because all the entries are n, so that's why it would be n. Trace of null matrix would be 0, and trace of AB. Now one thing you should remember, that trace of AB you cannot write down as trace of A, trace of A into trace of B. You cannot do that. That trace of AB is product of trace of A into trace of B. That would be incorrect. Trace of AB would be equals to trace of B. Trace of A plus B can you can just write down individually trace of A and trace of B, but not AB. Right? Now, next thing we have here is triangular matrix. So the question arises, what is a triangular matrix? So triangular matrix, basically, if you would see, we have two matrices here. One is lower triangular, another one is upper triangular. Upper triangular. If I'll talk about lower triangular, so if I have all the elements below the diagonal, all the elements above the diagonal are 0, then it is my lower triangular matrix. Let's say I am writing this. So you can see that the elements above the diagonal, what is the diagonal? This is a diagonal. Above the diagonal are 0. So that's why it is my lower triangular matrix, because we are getting a lower triangle. Similarly, if I write down upper triangular, that means elements below the diagonal are 0, then I'll say that it is my upper triangular matrix. So it will be my upper triangular matrix. Just a minute. So we'll have a upper triangular matrix if elements below the diagonal are not, elements above the diagonal, below the diagonal are 0, right? Because we will get a upper triangular. So below the diagonal are 0. So this is my upper triangular matrix. So the definition of lower triangular matrix, can I say that Aij is equals to 0 if कौन सी lower triangular में कौन सी entry 0 है? Like you can see that this is A21, A12, A13, A23. If I is greater than j, if I greater than j, row number is greater than column number is 0. A21, A31, A12, उल्टा लिख दिया मैंने. I just have written it. I less than j, because this entry is A12, A13, A23, right? A22 is not 0. All other entries may or may not be 0. All other entries may or may not be 0. But the condition for lower triangular matrix is that all the elements above the diagonal are 0. So that means Aij is 0 for I less than j. Similarly, in this matrix, you can write down for upper triangular matrix, Aij would be 0 if I is greater than j. Similarly, you can see that A21, A31, A32, all these entries are 0. So this is my definition of upper triangular matrix. So this is the definition of lower triangular, this is the definition of upper triangular. But if we are looking at a matrix, we can see directly that elements below the diagonal are 0, upper triangular, elements above the diagonal are 0, lower triangular. But sometimes they can provide this thing in the question, right? If they have given this thing, so you have to understand that they are talking about lower triangular or upper triangular, right? Now the question arises that 0, 1, 0, 0. Is it upper triangular or lower triangular? This matrix is upper triangular or lower triangular. So you can see that what you need for upper triangular, the elements above the diagonal. The elements for upper triangular, you need that the elements below the diagonal are 0. That is 0. If the elements on the diagonal or above the diagonal are also 0, that would not matter. The only thing matter is the elements below the diagonal are 0. Right? So it is an upper triangular matrix. You cannot say that it is neither upper triangular nor lower triangular. So it is upper triangular matrix. Also similarly, if I'll talk about null matrix, null matrix is both upper triangular and lower triangular. Similarly, if you would take diagonal matrix 1 2 3 0 0 0 0, it is both again upper triangular and lower triangular. And one thing you should consider that it should be a square matrix. Square matrix with these conditions. ठीक है, ये कंडीशन होनी चाहिए. Triangular matrix is square matrix with conditions, and conditions are this individually, right? So that's how we define our triangular matrix. So, and one more thing you can see here, that if you would take a transpose of a lower triangular matrix, you would get an upper triangular matrix, and if you would take a transpose of upper triangular matrix, you would get a lower triangular matrix, right? So yeah, next we have further question that note we have minimum number of zeros in a triangular matrix is given by n into n minus 1 by 2. Why is that? You can see that if you would write down any triangular matrix, let's say it is of order 3 cross 3, so the elements above the diagonal are 0 if it is a lower triangular matrix. So these many numbers should be 0. And how you get? First row you have at least 2 zeros, you have 1 0. You can have more than 0, right? So 2 plus 1 3. Similarly, for let's say you would have 4 cross 4 matrix, so in first row you have, so on diagonal entry, let's suppose you have a 4 cross 4 matrix, so it is a diagonal, so you should have these 3 values 0, then 2 value, then 1 value, and then 0. So that means minimum number of zeros required 3 plus 2 plus 1. That means 6. And how do you get this 6 value and this 3 value? You would get with this formula n into n minus 1 by 2. You would get it from that, n into n minus 1 by 2. You can check that. 3 into 3 minus 1 by 2, you would get 3. 4 into 4 minus 1 by 2, you would get 6. Right? Diagonal matrix is both upper triangular and lower triangular. That I already told you. Similarly, null matrix is both upper triangular and lower triangular. Right? So we have here both, we have discussed the properties of upper and lower triangular. Now, from next video onwards, we are going to cover symmetric matrix and skew symmetric. That means we are going to complete our types of matrices, and then we are going to discuss inverse and determinant. First we are going to discuss determinant, and then we'll move to inverse. And while discussing all these things, we are going to solve gate questions as well, gate previous year questions. Okay, so yeah, that's all for this video, guys. I hope this series would help you. If you are getting information from that, so just subscribe the channel so that you would have all the concepts clear. You can join for another session, you get a notification for that. You would not able to see that video. So just subscribe the channel. And also one more thing, while I am in this video we do not have any questions, but moving forward we are going to solve questions as well. So make sure when I am solving the question, you are also solving with me. Or when I start a question, just take a pause there, because usually in live classes what we do, we give students time to solve. So because it is a recorded format, so I'll just pause it. You guys just pause it, not I, right? You guys just pause it and try to solve it by yourself, and then move to the solution, right? So from now onwards, that would be your approach. If you are if you are seeing any recorded version, right, that would be the right way to see the recorded videos. Otherwise, you should not be able to solve question by yourself. And also one more thing, I'll also suggest for you guys to make the notes. Right, just try to make the notes with me. I'll share all these PDFs. You would get the link in description where you would get all the notes here. And one more thing, what you had to do, you just have to make your own notes, because when we write by ourselves, we'll be able to learn more, right? We'll be able to keep it remember for a longer time. And humko to we have to give exam in February, so for that time I just need to remember all these things. Okay, so yeah, let's continue in next video. Thank you, guys.